So now we need to actually configure these drives. Like I said, we've installed everything onto these drives, but now we need to boot back into these drives and configure them. So what we want to do is we want to run the virtual machine again. So I'm going to do that with this command here. We're running basically the exact same command. If you had to take out the BIOS information, then do that again. And the only change we're making is we're not booting from a disk. So previously we said boot from this disk. And we pointed to an ISO file. We're no longer doing that. But also what we're now doing is we're now additionally saying, hey, we want to have a network device also attached to this machine because we're going to expose SSH over port 2222. So we can run this. And once again, it's going to start the virtual machine. Because it's a virtual machine, it obviously takes a moment to spin up. But what we can now do is we can go to another terminal and we can connect to this this machine. And now what I can do is, remember I exposed SSH over 2222. So we can specify the port when we're doing SSH. And we can say we want to connect to root at localhost. So yes, we want to add the fingerprint. And now we want to add the password that we added when we were installing Proxmox. The root password is the Proxmox password. They are the same thing. Now we're inside of the virtual machine, let's start configuring things. So let's start with doing apt update so we can download the latest packages, and we're going to get error messages here, which basically says we cannot download the enterprise libraries for Proxmox. This is because we don't have an enterprise license. And now we can do apt install, and we want sudo and vim. So first things first, let's fix this error message that we saw when it came to the repositories. So we go to our sources file and we go to in here, and we should see PVE enterprise. Copy this line and change it to HTTP, change enterprise to download, and change PVE enterprise here to PVE-no subscription. And then we want to go into the Ceph file. So what I'm doing is I'm doing Shift-Y, Shift-P, and this will clone a line like that. And once again, we're going to change this from enterprise to download. Instead of enterprise for this one, it's just no subscription, like that. So now we should be able to do apt update. We'll be able to get all of the dependencies without error. So now we can do an upgrade. And this is going to install all of the down updates for Proxmox. Okay, awesome. Now this is done. Let's start actually configuring things. Now, working as root is kind of dirty, in my opinion. So what we want to do is we want to start off by creating a new user. I'm going to call it node. And this is going to be the default user to operate the system. Please do not, especially with something connected to the internet, have root as that default user. It's just, in my opinion, asking for trouble. So I'm going to make this node user have sudo access. That's what I'm doing here. And I want to give it a password. Now, I recommend you give this a different password to root, but that's at your discretion. Now, let's go to the password D file. And I would just want to change the default shell as I did here from bin sh to bin bash. And now what we want to do is we want to make it so that you're forced to use this account when you want to log in with SSH. So we can see here, permit root login. Let's make that no. And we're going to have to restart SSH to have those effects taken place. So now let's just quickly become node. So su node, just make the SSH folder like this. We can exit out. Because what we want to do is, because I logged into rescue mode with my SSH key, it means on rescue mode, it has my public key already inside of my authorized keys. So I'm going to copy my authorized key into the machine. We want to make sure we specify port 2222 when we do this. Specify node as the user, because we just made it so we can't connect with root. Also, the thing to be aware of with SCP, annoyingly, is that you have to use the capital P, unlike SSH, to define the port, which is the lowercase p. Let's go back into our node, and we can validate, and we should validate, by the way, that we cannot log in with root. It's quite important that we make sure root is actually blocked. So next up, DNS. I don't want to use anything from Hetzner. I want to use the big providers because I trust the results more from their system that is going to be correct. What I'm going to do for a lot of these configuration files is I'm going to comment out the configuration that they come with. And the reason why I'm doing that is in case in the future I ever want to put it back for maintenance purposes. Now I'm using 3 name servers here for now. One of them is Google, the 8888, and the other 2 are by Cloudflare. Next up, let's actually find out our interface name. So exit back into rescue mode and do IP addr so we can see our different interfaces. And we see we've got the loopback interface here, and we have the Ethernet interface here. And you'll see it says alt name and then an interface name here. So ENP7SO. This will be different on your machine. So please check and see what this interface is, because it's very important you get this bit correct, or otherwise you're not going to be able to connect to your machine. So we can see it's ENP7SO. Now let's go back into our virtual machine here. So let's copy over the current configuration, which is under etc network interfaces. And we want to just copy this. So in the future, if we ever want to come back into rescue mode, we can do so into this folder here. So let's go back into that. Okay, so this is just the default interface that Proxmox configures for us, and it's based on the configuration settings we did on installation. I like to keep this lying around in my system. It's just my preference, because if I want to come back into rescue mode and do maintenance, initially I can't connect via SSH, but if I re-enable these different configurations, SSH will be working, which in my opinion is a lot better way to manage a system than VNC. So I just removed the extra configuration outside of the interface definition and the bridge definition. So let's rename the bridge from VMBR0, which stands for Virtual Machine Bridge 0, and let's give it an explicit name, Rescue Bridge, so we can always identify what this is in the future. Now, Proxmox itself won't pick up this interface because it doesn't follow the naming convention that Proxmox uses, and also Proxmox doesn't read any interface definitions in this folder. So let's go to our actual network interfaces configuration. And this is, once again, this is the actual networking definition on our system. Let's shove in a configuration to begin with. So here's an example configuration I have. Up here, we have defining the loopbacks. And what we want to do here is we want to initiate our interface. And if we remember right, it was ENP7SO. This line here will load in our rescue bridge interface we just created. In the future, you can always comment this out if you don't want to load it in. But what we want to do right now is we want to come down here to VMBR0, and we want to change the address to our node's IP address. So the way we do that is we go over to Hetzner, we go over to our machine, we come over to IPs, we grab this IP. It's the exact same IP we've been connecting to the whole time, but we need to go there because we're going to need our gateway information in a second. So we want to put that there. Double check the CIDR block here. For me, they've always been /26, but just double check that. The way you do that is you just look up the net mask here. So 192 is a /26, for example. We want to grab the gateway from here, and we want to put that on this line here. Put our interface back here again, so ENP7SO, like this. This is all done. So basically what this is going to do is it's going to create us 2 interfaces. VMBR0, which is basically going to be our route to the internet. And this is also how we're going to be able to connect to the machine itself as it is. Then we have VMBR2, and this will be our private network that we're going to put our virtual machines on. And this is why we're defining a private address range here. Down here, we have these IP tables configurations, and these will configure the virtual machines when they're spun up with these IP table rules. And we're basically saying that any connection that comes from these sources will instead be routed through VMBR0, which basically allows them to have a networking connectivity. Basically, we're setting up a NAT. So they can connect to the internet without having public IP addresses. Okay, all the VMs will be able to communicate on this private network. And what we want to do is we want to do IF reload. We want to reload our interfaces, and we want to see if we get any errors. So this is the error I fully expect you to get, which basically says this interface doesn't exist. Because inside the virtual machine, it doesn't have this interface. So we can see here, if we look at the interface in this virtual machines, for the Ethernet one, it doesn't say alt name ENP7SO, it gives it a different name. So That's why we get that error, and that's exactly the error we want to see. The reason why we run this command, and the reason why I recommend you run it, is because if you have any other errors inside of your interface definition, it will also appear here. Because if you have any errors in that file, it could mean that you can't connect to your machine after you boot into it. And then you have to come back into rescue mode to do maintenance to fix it. One of the other important things we want to do is we want to configure our sys config file. So what we want to do is we want to come down here to uncomment these lines here, which will allow us to do packet forwarding for IPv4 and IPv6 on this machine. Additionally, we want to add an entry to our modules file for NF contract. This is also used for NAT and will allow us to have a stateful firewall, basically. So it uses it for NAT translation. Then double check you've done everything correctly, because we're going to try to boot into this. So let's do sudo power off. Now, what we just did, remember, is we powered off the virtual machine. We're still in rescue mode here. We just powered off the virtual machine. And in the other tab, it will take a moment to end this command. I highly recommend you wait until this command finishes and you come to the terminal like this, because that means it's powering off the virtual machine. So just wait for it to fully power off the virtual machine. And once you've done that, we can now reboot. Now, because I'm lazy and I know it's going to give an error, I'm just going to delete my known hosts file, because we're going to try to connect back into this machine, but not through rescue mode. So it looks like the server's up, so let's try and SSH into it. We're going to get this to confirm the authenticity, and let's put in my password. Now, I tried to log in right now with root. Now, this shouldn't work. Good. Let's log in with the right account now, which is node. So that's the only difference from the previous command, and bam, I am in. The reason why I logged in instantly without giving it a password is because we copied over the public key for SSH. So we copied over the public key for SSH, but we have a problem, which is I can still authenticate using the password. So what we want to do is we want to log back into our machine, and let's fix that. So let's go to my SSH configuration. Now, the reason why I didn't recommend you to do this before is because it's good to do this after we can validate we can log into the machine. And we should be able to find this line here, which says password authentication yes. And let's change that to no. So we have disabled password authentication. And obviously, to apply this, we need to restart SSH. Like so. What you can also do at this moment, because we've created the node user, is we can also create a PVE, a Proxmox user for the node user itself. I'm going to skip this in this video, but I highly recommend you do that to properly segregate out your users. Now, IP tables. So I told you before, we opened up the UDP ports, and I believe UDP to be quite insecure, not because UDP is a problem, but when you use UDP, you should lock UDP down. So we should say only these sources can send me UDP messages. And the way that I'm going to do that is with IP tables. So I have this command here, and we're basically saying in this command here that I'm going to allow connections from this source here, 8888 for port 53. So this is DNS. So I have to run it with sudo. And let's do the same thing with 4s and 1s, because these are the DNS entries that I set up. And then any other request that comes in, we want to drop. And I can see right now that we're going to accept DNS from all these entries, and then anyone else, we tell them to bugger off. Also, we opened up NTP before. It's very important when you run things in a clustered environment that you keep time in sync. If time goes out of sync, then your whole system can fail in disastrously weird ways. So let's set up time syncing. So I'm going to use this tool here. We want to install this. Now, by default, when you install systemd timesyncd, it will retrieve time information from the Debian servers. Now, once again, I'm going to log this down, but I usually prefer setting this to the Cloudflare servers. And the reason why I use the Cloudflare service is just because I use Cloudflare for other things too. So it's nice to standardize my source input from one source rather than loads of them. So in order to do that, I want to edit the source for this. So we go here, timesyncd config. Here we should see that there's a line here that says NTP equals. Let's change this to time.cloudflare.com. And so we're going to get our time information from Cloudflare. In order to apply this, we have to restart the service like such. So someone made this lovely post on GitHub. And basically what it is they loop through all of Cloudflare's IP addresses for v4 and v6 and open up certain ports in IP tables like here. We're going to steal this script and use it for DNS. I've already done that here. So we're going to loop over all of their IP addresses and open up port 123 for UDP, and then we're going to block everyone else. So let's run this. And now I can see my full IP tables definition like this. So we can see we have lots of entries now. We're going to allow all of the DNS and NTP entries from people we trust, but everyone else we're going to block. And now we can validate that everything's working fine with datetime.ctl status. And we can see that we have everything synced. It says so here that things are synced, and that we're using UTC. So we're not using daylight savings time. Both of those things are quite important. Problem with IP tables is if you restart your machine, you lose all these changes. So let's install IP tables persistent. And when we install this, it will save our current rules, which is what that wizard there suggests. Right, now, we're almost done. We're almost going to create our first virtual machine inside of Proxmox. The next thing to do is we want to download an ISO file for an operating system that we want to run. Once again, I'm going to just use IPv4 to download with, and let's download Fedora, because the nice thing about Fedora, as I hinted earlier, is it has a live ISO. This is really nice when you just want to test out the networking without having to install the operating system. So we're going to download Fedora into this directory here, which is the special directory which Proxmox uses when you're creating a virtual machine to see what ISOs are available. One very important thing is by default, Proxmox enables the RPC bind service, which we definitely want to disable unless you specifically need this. Now, the reason why we want to do this is it allows RPC servers to expose themselves dynamically and for other people to find them. So let's just disable this unless we explicitly need it. Also, we have almost done, I promise you. Let's configure our ZFS. If you remember, it's our file system, because by default, it consumes quite a lot of resources. And we just want to be strict with our resource consumption. We want to come into this file here and we want to configure it by saying this is the minimum set of memory it can use, which is in my configuration here, I'm setting it to 4 gigabytes and I'm setting the maximum to 8 gigabytes. So I recommend you to look up what you should make those values and make a conscious decision yourself. You can see yourself, just so you're aware in the future. You can see the current usage when you do arcstat, or additionally, you can see information when you do zpool iostat -v, and we can see information about our drives. We have to apply these changes as such, and this only gets applied the next time the operating system boots. Now, it's very important that you don't use up all of the memory inside of your cluster with the virtual machines, and you always make sure ZFS has all the memory it needs. So always have that buffer zone between your virtual machines and ZFS. And the reason is because if you have Linux virtual machines, they like to consume as much RAM as possible with cache files. So what this means is Linux will always try and cache things in RAM. You don't see this when you're using Linux naturally, but it's always trying to cache as much as possible in RAM. Linux doesn't always show you this as RAM used because it frees up this RAM instantly when needed. And this all works perfectly fine and is lovely, but it confuses the host. The host doesn't know which RAM is in cache and which RAM is just used, right? So we want to make sure we have this clear separation between ZFS and virtual machines in the RAM usage, because if you don't, the host might kill the virtual machine for consuming too much RAM in an effort to save ZFS. So that's something to be aware of. We're done. Let's reboot. So it's going to take a while for the machine to come up again. Once again, we can start pinging and see when it's available. So now once everything has come up and we're getting our pings here, we can actually go to our browser and go to the IP address on port 8006. I'm connecting to the domain name because I put a domain name in front of my, it'll tell you certificate authority invalid, but just come here and just go to proceed under advanced. So let's log in with the root password. This is Proxmox, and from here we can manage our different nodes, manage the networks. I highly recommend you just spend half an hour going through every interface and just seeing everything that's there. You can even access the shell for the node from Proxmox itself like this. So just play around, just have a look what's available. So let's go up here to the top right and do create VM. Let's give it a name. We can go through operating system, ISO image. We want to specify the Fedora one. Just keep going across, leave everything at default. We're not going to have a very fast machine. We're just going to use the defaults. And let's set the bridge to VM BR2. So remember, this is the one which will have a private IP address and will be behind a NAT. And from here, we can just go over to confirm. It gives us all the information. We can say start after created and just press finish. So give that a moment, and we want to come under here into PVE1, and we can see our virtual machine here with the ID of 100. So it's currently maxing out CPU while it's starting, and we want to come over to console, which is how we can see what the virtual machine is doing. So we can see here it's booting into the Fedora live disk. Now, once we're inside of the operating system, we can say not now to the installation because we're not going to install Fedora. We will notice if we go to the terminal that we don't have internet connectivity. So we can go here and we can try and ping the internet, and it will say network is unreachable. So if we go to the top right, we can go to the cogwheel here, go to configure the network there. So go to IPv4 and say manual. Let's go over to DNS, and for a moment, let's just put in Google like this. For address, so 192.168.192.100. And the net mask for this is .192 here. The gateway is also coming from our network file. This is .5. So we can validate this information ourselves if we cat, etc. networks interface here. And we can see here, so we want an IP in this range, which we have. We have a .100. The net mask matches a /18. For gateway, it's literally this IP address here, the .5. This is the gateway. So let's press apply, and we go to ping again. We're now connecting to the internet. We're now connecting to Google. And what we can also do is we can see if DNS works as expected and if we can receive the response. There you go. So I'm connecting to Google's website and downloading their homepage. That is a bit annoying every single time you start a virtual machine to have to go in here and manually configure it. So let's fix that. Let's install DHCP. So on the node, I'm going to do this relatively simple because I'm going to have a DHCP server per node. Now, when you install it, it gives you a bunch of errors to begin with. Ignore that. It's just being dramatic. So let's go and configure the DHCP server. And we do that by going to the configuration file. Let's go all the way down to the bottom. And I'm going to put in this configuration. Basically, we're saying for IP addresses in this range, IP addresses with this IP, but in this net mask, so in this subnet, will be granted this range of IP addresses. And then we're going to fill in the various information as we did manually, but automatically through the DHCP server. So you can see we're also going to give it these 3 domain name resolvers here. So let's save this. And now let's edit this other configuration file because we want to specify which interface we actually want to create these records for, which is VM BR2 under V4. So I'm not going to do anything for V6 right now. Now, once we're done that, we should be able to just restart our DHCP server, and we should not get errors this time. And we can also enable it, though I think it's enabled by default. And now if we come back to our virtual machine, make it smaller, I can restart the machine now. So by restarting the machine, it's not going to persist the configuration I gave it because it's just a live disk. And we can see if the networking works by default. So now the machine has booted back in. We can go over here. It's already giving me a positive symbol here for networking. So I can go straight into the terminal and I should be able to connect straight away without having to do any custom configuration for this machine when it starts. We can also see if I drag this over that it has been assigned an IP address inside of the range we defined before. It's giving it a .0. And if I go over here to my network configuration, we can see it's retrieving this from DHCP. So here we go. So this is how to set up a basic Proxmox installation. If we were to create another virtual machine inside of the same node, it will be able to communicate also with this virtual machine with their own private addresses if they're in the same network VMBR2. So that's the end of this first video. I'm going to make another video. I'm going to make another follow-up video where we now put this into a cluster. So we have multiple machines all inside the same Proxmox cluster, all able to talk to each other on Hetzner, even though with Hetzner you do not have a LAN available to do so. And that'll be the next video. So thank you very much for watching this video. I hope you guys have a lovely day, and I hope this was easy to follow.